Yeah, I heard him too. I didn't bug him about it. I figured I'd leave it for you. I didn't want to steal your thunder, Jashin. I knew you'd want to get in on that. All right, that's where we are right now. It's everybody cool. Everybody can handle this question, yes? It's easy peasy lemon squeezy, agreed? Oh, yeah. Okay, now, look in the instructions to this question. Is there a new word there that we haven't dealt with? In the instructions. The instructions to the question. What's the word there that we haven't talked about? Restrictions. But you do know about restrictions. For example, what is, and don't write this down, just you know this, 6 over 2 equals what? 3. Everybody cool? Okay. 6 over x minus 2 equals 3. Could you solve that? Yeah, you know how to do the algebra to solve this. We all, and besides, we know the answer is 4, right? Because we can do it in our heads. Everyone cool? Okay, now, what is never allowed in a denominator? What is not allowed to be in a denominator? What's the only thing we cannot divide by? Yes, we can't have 0 down there, right? Because 6 divided by 0 doesn't exist, right? So before we do any math on this question, we know that x could never be 2. Why do we know that? Because x minus 2 cannot equal 0. So x cannot equal 2. Everybody already knows that, right? Even though you may never have heard it described as such, every one of you knows that you can't have 0 on the bottom of a fraction, right? So this is what we call a restriction. This is the other new thing I was telling you about that you already know, but you've never applied it in this way. Everybody cool? All right, so now let me ask you this. Again, don't write this down. This is brain work. What is the square root of 9? The proper square root of 9. That's the principal square root of 9. What's the actual square root of 9? So it's plus or minus 3. The principal square root is positive 3, correct? That's our principal. Everybody agree? Okay. The square root of x plus 3 equals 3. What must x be? 6. Everyone's cool with that, right? because the square root of 9 is 3. Everyone understands that in this case, x equals 6, yes? And of course, you also know how to solve this, don't you? Because we've just done that. We would square both sides. We get x plus 3 equals 9. We take 3 away from 9, we get x equals 6. And we'd all be good, right? All right, now, what is the square root of negative 4? Think before you answer. Think before you answer. I'm writing this out and I'm telling you to think because it's not the first thing that's jumping into your head. You can't square root a negative number. Why, Emma? Right. This has no root because negative 2 times negative 2 equals positive 4, yes? So, if something happens once in math, how often does it happen? Always. So, am I allowed to square root any number x if it is less than 0? No, never. This is not allowed, is it? All right. So now that you all know that, you remember that from back in the day, where in this equation do I have to be careful? Where will a restriction lie? In the root, right? This right here, which is going to show up green, can't be negative because you can't square root a negative number, right? So, our restrictions come up like this. Restrictions, circling in green, follow the arrow. 2x minus 1 is not allowed to be negative, is it? So 2x minus 1 must be what? Greater than or less than 0? Greater than, can it equal 0? Does 0 have a square root? Does it? 0 times 0 is 0. So can it equal 0? So 2x minus 1 has to be greater than or equal to 0. Everybody understand? Now, in the 9th grade was the last time you saw this. Remember how I told you at the beginning of the year, every single piece of math you have ever done is coming back in grade 11? So I taught some of you in grade 9. You know how to do inequalities. If you weren't in my grade 9 class, you're going to learn real quick right now. Does an inequality change how we do it? What's my goal whenever I have an expression with an x in it? Or a y, or a p, or a q? Isolate it. So let's isolate that. 2x must be greater than or equal to what? No. I'm isolating x. That 1 has gone somewhere. Where? To the other side. So 2x is greater than or equal to 1. Now what? X is greater than or equal to 1/2. Now, we found our x to be what? What was x in this question? 25. Is 25 greater than 1/2? So it's okay. Everybody with me? This is the new thing. How many people need to be reminded about how to do inequalities? It'll take 2 seconds. Be honest. Okay. It's just algebra with one little wrinkle. 3x plus 3 is greater than or equal to 12. 3x is greater than or equal to 9. X is greater than or equal to 3. What does that mean? That means every number bigger than 3 works in this equation. We all remember this, right? You may have had to put it on a graph. 3, color it in, draw the arrow. You all saw that in grade 9, right? Okay. Here is the only wrinkle. Watch. I'm going to change this to negative 3. So now, negative 3 still is greater than or equal to 9. I divide by negative 3, correct? So this answer becomes negative 3, yes? Will this work now? It says x is greater than or equal to negative 3, right? Give me a number greater than or equal to negative 3. Any number that's greater than negative 3. Please say 0. Awesome! Way to go, guys. So x is greater than or equal to negative, or 0 is greater than or equal to negative 3, right? Which means if we did this right, 0 should work here, yeah? Okay, what's negative 3 times 0? 0. What's 0 plus 3? 3. Is 3 greater than or equal to 12? No. So the only trick you have to remember is if you ever multiply or divide, because multiply and divide are cousins, if you ever multiply or divide by a negative number, you flip the sign. The inequality sign. So this becomes less than or equal to negative 3. And then this would work. Everybody with me? And of course, it would work because negative 4 is less than negative 3, right? Negative 4 times negative 3 is negative 12, or is positive 12. Positive 12 plus 3 is 15, and 15 is greater than or equal to 12. Everyone remembers this from the 9th grade, right? Okay. Let's start applying this. Now, you all already know how to do this question. You have everything already. The only new thing we've added is restrictions, right? So should we do our restrictions first or last? What do you think? I would do them first because then you know what the answers are not allowed to be, right? Then if you do the work and you get an answer that isn't allowed, you know you can stop, right? So where in this question do the restrictions lie? Where's the only place we have to be careful? Under the radical sign. What is under the radical sign right now? Which, by the way, is called the radicand, which you also already know. Where do I have to worry about the radicand? 5 minus n has to be what? Positive, which means it must be greater than or equal to 0, yes? So negative n must be greater than or equal to negative 5, correct? And then I divide by negative 1. What happens when I divide by negative 1 to that sign? It flips. N must be less than or equal to, what's negative 5 divided by negative 1? Positive 5. So when I do all this work, n has to be less than 5. If it's greater than 5, it's not going to work. And we know that already. Everybody cool? So now let's do this. What did we say our first step was? We just wrote it on the page. I'll slide back up. What's our first step? Isolate the radical. Can I get that radical isolated? What has to move? The n. So we're going to move that n over here. What's going to happen to it? It's going to become what? Negative. So I rewrite, and I have negative root 5 minus n equals negative n minus 7. Everybody agree? Okay. What would be the next thing to isolate our radical? What's right here that isn't really here? Negative 1. How do I get rid of negative 1 times that? I divide by what? I do this one in red. Oh no, I'm still isolating the radical, so I'm keeping in black. I divide by negative 1. If I divide this side by negative 1, what must I do over here? Divide by negative 1. And now I have the root of 5 minus n equals what? N plus 7. Nice. Is our radical isolated? Have we finished the first step? What is the next step? Eliminate the radical by squaring. Square, square. This is now 5 minus n. Agreed? Is this n squared plus 49? No. What is it? n squared plus 14n plus 49. Everybody agree? Have I isolated the radical? Yes. Have I eliminated the radical? Yes. What is the last thing to do? Solve. Well, this is a mess. What do you see there and there? Like terms. What do you see there and there? Like terms. Have we been through grade 9 and 10 in math in Canada? Do we know what to do with like terms? What do we do with like terms? Collect them. Let's do so. This n has to come over here. What's going to happen to it? I do this part in blue. So I'm going to have n squared plus n. So this is plus 15n. And what's going to happen to this 5? It's going to become a subtraction, yes? So what is 49 minus 5? Yeah? Everyone agrees? What did I leave here? 0. Does this look like something we've dealt with? It looks pretty familiar, doesn't it, at this point in our factoring unit? Doesn't it? What are you going to do with that? So here we've got a new step, but it's not a new step, is it? It's still algebra. Here we're going to factor, and what are we going to get? N. What are the factors of 44 that add to 15? Is it 1 and 44? Is it 2 and 22? Is it 11 and 4? Yes. N plus 11, n plus 4. And what does that equal? 0. Now, think back to our warm-up today. Is that a factor? Is that a factor? So for this multiplication to be 0, one of those factors must equal what? One of them must be 0. So either n plus 11 has to equal 0, or n plus 4 has to equal 0. When we solve those, n equals negative 11, and n equals negative 4. Those are our two possible answers, correct? N has to be less than or equal to 5. Are both of them less than 5? Yes. So they meet our restriction, don't they? So they are possible answers. What is our last step? Plug them in and check. And we do that in green. What is 5 minus 4? 9, right? What's the square root of 9? 3. So here, what's n supposed to be? Negative 4. Is negative 4 minus, what's the root of 9? 3. Is negative 4 minus 3 negative 7? Is it? Sure it is. So is this answer right? Yep. Now let's check the other one. What's going in for n? Negative 11 minus, what's 5 minus 11? 16, correct? Okay. What's square root of 16? 4. Is negative 11 minus 4 equal to negative 7? No. So is negative 11 allowed? No. This is what we call an extraneous root. And the only reason that exists is because we had to square this. We had to square it to get rid of the radical. That opens up the option to a root that doesn't exist. Is everybody cool? Avni.
So we just do the inequality to see, like, to get an idea of what the answer's going to be?
We do what?
The inequality part. Just
No. Because sometimes you're going to get an answer here that doesn't work here at all. Right? That's why we're doing it. Let's say, don't write this down, but let's say we do all our work and we find n equals 3 and n equals 8. But n had to be less than 5. So do I even need to check 8? No, because 8's bigger than 5. That's why we do the restriction. Okay? Is everybody cool? Please notice it's a lot of work, isn't it? It is complex, but it is not complicated. Right? Because what math are we applying here? Did we apply anything new until extraneous root? No. We're doing regular algebra and factoring that we have done starting in kindergarten, right? Your very first day of math, you did algebra, even though your teacher didn't call it algebra. Because if Jashin has 5 apples and Harkirat has 5 apples, how many apples do they have? 9. 5a for apples, right? 5 plus 4 equals blank. If there's a blank, you're doing algebra. Except in grade 6, we change that blank to what? X or A or any other letter. And we start calling it algebra, and then everybody gets scared of it, even though you've been doing it since kindergarten. Right? Okay, let's look at the next one. Easy peasy lemon squeezy, right? Is the radical isolated? Yep. So do I even need to do step 1? No. So what's step 2? But have I forgotten something? I should probably check my restrictions, shouldn't I? Let's check our restrictions. 2 minus p has to be greater than or equal to 0, right? So negative p has to be greater than or equal to negative 2, so positive p has to be less than or equal to positive 2. Everyone agree? Do you have to be able to do it that fast? No, but you have to be able to do it. Right? I don't want to spend a lot of time on the grade 9 algebra. Everyone okay? Now, what does that mean? This is what Avneet was just asking about. If I do all my work over here and I get any p that is greater than 2, do I even need to check it? No, because it's not allowed. All right. So I'm going straight to red ink. Why? Why am I going straight to red ink? Because the radical's already isolated. So I'm going to square both sides. And what do I get? P squared equals 2 minus p. So now what should I do? Do I have any like terms? No. But I have a squared, a regular, and a constant. We've seen this before. That's a trinomial, isn't it? So let's make it a trinomial. P squared, what's going to happen with that p? Oh wait, we got to change to blue because now we're doing algebra. P squared plus p minus 2 equals what? 0. We know what to do with that. What is it? Factor it. So factor it for me. What is it? I need numbers that do what and what? Add to 1 and multiply to negative 2. What are they? 2 and minus 1, right? So p plus 2 and p minus 1, correct? So once we're here, what do we know has to happen for this to be true? Something's got to equal 0. So either p plus 2 has to equal 0, or p minus 1 has to equal 0, which means p equals negative 2 or p equals 1. Are both of those less than 2? Yes. So they meet the restrictions. Is it possible one of them is extraneous? Yes, because we have 2 answers. So let's check. What is 2 minus negative 2? 4. Everyone agree? So with this one, I've got, and what is supposed to be on this side? Negative 2. Negative 2 equals the root of 2 minus negative 2. Agreed? Negative 2 equals the root of, what's 2 minus minus 2? 4. What kind of root am I looking for? The principal root, right? So even though the square root of 4 is plus or minus 2, we only care about the positive one, yes? So, does negative 2 equal positive 2? Not in my world. So is this a real answer? No. That is an extraneous root. Let's check 1. Now I'm writing this all out, but you can often do this in your head, can't you? The checking. 1 equals the root of 2 minus 1. What is 2 minus 1? 1. 1 equals root 1. What is the root of 1? 1. Does 1 equal 1? In my universe, so the only right answer we have is that one. Is everybody cool? Now, before I answer your question, Jashin, we've done very easy factoring, haven't we? Or any of the factorings we've done available to me to use here as the teacher? Can I give you a question that doesn't give you this? That isn't the nice easy one. Could it be plus 12? Could it be that? Yeah, you would just factor it and solve it the same way. Is everybody cool? All right, Jashin, go. Okay. I would like for everyone to try D on their own. Talk to your neighbor. You don't have to do it on your own. You know what I mean when I say try it on your own in this situation, right? You're going to try it on your own. I'm going to write it out with the screen off using all the different colors, and then you're going to check it yourself. I'm not going to walk you through it. Are you asking to go somewhere or do something? Oh, of course it's time to go to the washroom. I'm asking you to do some work. How we doing? Yes, it would. Well done, Argyrit. That's absolutely correct. What you have done there, yes. By moving 19 to the right, you get negative 15 on the right. Again, remember, complex, not complicated. You have to be very careful with your operations. If you feel you've got it right, and I haven't shown you yet, turn the page over and see what you can do with E. guys got it yet? All right, everybody should be good by now. What is the right answer? Somebody guess. I mean, you're practicing. What's the right answer? Pardon? N equals 5. Yes, 5 is the correct answer. Here is why. Everybody should have been good with the first one. I move the n over, right? I square both sides. I collect my like terms. I get to here. N, negative 3, n, positive 5. There are my choices, yes? Then I check them. When n is negative 3, I can check it right here. Negative 6 times negative 3 is negative 18. Negative 18 plus 19 is positive 1. Negative 3 plus 2 is negative 1. Does the square root of 1 equal negative 1? No. So 3 doesn't work. And of course, you remembered to check your restrictions.
Wait, so how come the 3 is positive?
Okay, so right here, I did a shortcut, didn't I? Because I've just done 3 other questions. Please notice, p plus 2, p minus 1. What were my possible answers? Negative 2, positive 1. See? So here, as soon as I get to here, I know it's going to be negative 3 and positive 5. I'm not even finishing the question. I'm not actually doing this because I've done it now 3 times. If it happens thrice in math, how often will it happen? Always. So right away now, every single one of you should be able to tell me the possible answers to that. What is it? Negative 7, positive 6. What about n minus 3 and n minus 5? What are the possible answers there? 3, 5. What about 3 minus n and 5 plus n? Uh-oh. Harder to do in your head, yeah? If you can't see it in your head, then what must you do? Do the algebra. 3 minus n has to equal 0. 5 plus n has to equal 0. Then you just do the algebra. What if it was this? 3x plus 1 and x minus 2. Which one of them do you have to do the algebra with, Isabel? I forgot the a. Sorry. You got to do the algebra there. But this one you know in your head, right? Everybody good? All right. Look at 64. EFG. Does anything there look snaky? One thing there looks snaky. What is it? E, F, or G? Which one's gross? Why? Because there's 2 radicals. Right? So everybody start on E and F, give G a try. I'll walk around, I'll offer assistance. When we get to G, we'll probably have to... When you get to G, try following your normal algebra procedures and see what happens. Okay? Now, you guys are intelligent people. This much white space down here, what does that mean? What does that much white space always mean? Tricks that might happen to you. So let's get to the end of G first.
Yes, I know.
It's a ring. It's divided by 33. It flips around. It flips around.
That was frickin' funny. Woo. I need a moment with that. Woo.
What?
2 and 3.
Where?
I'm sure a great many of you were bothered by number 4. You should be, because there's no answer. And that freaks you guys out. How can there be no answer? Because there isn't. There is no value of x that makes that, or m, that makes that work. And there is all the reasons why. Where did you find it didn't work? Right here. Now look, ladies and gentlemen, let me show you a quick way to do your checking. Look at this right here, yes? Square root of negative 3m plus 10 had to equal m minus 4, right? Right? If m is 2, that's 2 minus 4, which is negative 2, correct? Can you ever have a square root equal a negative? No. Okay. So then you did it with 3 minus 4. What's 3 minus 4? Negative 1. Can a square root ever be a negative? So there's no possible answer. Everybody get it? Now where this is going to grow into, because everything we've done grows into the next thing, we're going to learn how to graph these. And when we graph them, you will see how no answer is possible. Okay? But until then, we're just working with the numbers. Everybody good? All right. Now, G. Who was scared of G? Be honest. All he is. All right. So, yeah, it's not too hard, is it? Even though there's two radicals, I'm supposed to isolate them, right? So which of those radicals is easier to isolate? Because what math is happening right there? Multiply. So if I had 2x equals 12, you would be doing some division, yes? Which one of those would you rather divide something by root x or the root of x minus 7? Root x, because it's easier, right? So if I do this, now I have the root of x minus 7 equals 12 over root x, yes? Now, we still need to get rid of one of those radicals, yes? Right? Which one is yuckier? Which one do you want out of your sight? You want the one on the right out of your sight? But it's just the square root of x. If x was 4, you would know it right away. Isn't this one yuckier? I think so. And watch what happens. I'm going to square that, yes? So what do I get over here? X minus 7, easy peasy. When I square this side, what's going to happen to that x? Square root squared. What's going to happen? It's going to disappear, isn't it? So I'm okay, right? What is 12 squared? 144. Over, what's the square root of x squared? X. Easy peasy lemon squeezy, right? Right? Okay. How do I get rid of that x now? I'm just doing regular algebra. What do I got to do to this side? Multiply. So now I have x squared minus 7x equals 144, correct? X squared minus 7x equals, minus 144 equals 0. And then I factor. Now, right away you want to go 12 and 12, but that doesn't work, right? So I got to find some other numbers. Is it going to be 1 and 144? No. What's it going to be? Positive 9 and negative 16. Okay. So x plus 9 and x minus 16 equals 0, correct? So what are my options? Negative 9 or positive 16. Then I go up and check. Can I get a square root of negative 9?
No.
So is 9 even an option? No. What's square root of 16? 4. What's 16 minus 7? 9. What's the square root of 9? Is 4 times 3 12? So what's our answer? 16. Gouda? We got rid of the root anyways. Cool? All right, now that you have seen two radicals, let's make it slightly more difficult. And this is the end of my notes, and I'm not giving you any homework, so stop.
Yeah.
I'll eliminate the whinging now. This is all we're going to do. On Monday, you're going to work on this. So, 7 plus the square root of 3x equals the square root of 5x plus 4 plus 5. Barf-tastic. But we have the haves. What do you want to do first? What's the first step always? Isolate the radical. Why is that a problem here? There's two radicals. Which one should we get rid of first? The yuckier one or the easier one? You want to get rid of the easier one first. Okay, that's cool. Let's get rid of the easier one first. Are you sure you want to get rid of the easier one first? Trust me. All right? Which one of those is yuckier? Right, so let's isolate that guy. So what's going to happen here? So I'm going to have 2 plus the root of 3x equals the root of 5x plus 4, correct? Do I have one of the radicals isolated? So now what's my job? Should I eliminate that radical that we're trying to isolate? How will I do that? I will square it. And I will get 5x plus 4. But here we're in trouble, aren't we? Because this is really 2 plus root 3x, correct? What is 2 times 2? 4. What is 2 times root 3x? 2 root 3x and then another 2 root 3x, right? So I have 4 root 3x. And then what's root 3x times root 3x? Root of 9x squared, which is 3x, right? Okay. Have I eliminated one radical? Where has that left me? What's left on the screen? There's like terms and there's another radical, isn't there? So what do I need to do to get that radical? Kill it. That's a little violent, Harkirat, but okay. We get rid of a radical by isolating it and squaring, right? Is that a radical? Can I isolate it? I think I can. 4 root 3x. What's going to happen to this 4? It's going to cancel because I got positive 4 and positive 4. Gone. Ah! I lie. You have one piece of homework. Finish that question. You got 48 hours to do it. You got to get home and photomath it.
I only use it to check my answers.
I know you do, buddy.
Get off my case.
I'm off your case. It was Harkirat that was giving you a hard time.